from outer space for more than half a century.
Silver disc hovering over the houses. We watched it.
It's not like talking to a human who speaks another language, where we all share.
When you aim a radio telescope at the stars, it's like putting your ear next to a loudspeaker. The sky is bustling with radio noise, from things like pulsars and radio galaxies, to disruptions in the atmosphere and interference from our own tech. For over 6 decades, scientists have been scanning the skies in search of extraterrestrial life. Yet the needle in this cosmic haystack, a signal from another world, remains elusive, given the incomprehensible volume of search space and our limited searches so far. But here's where the game changer comes in. The rise of artificial intelligence. AI is everywhere these days, from our everyday lives to cutting-edge science. And it's no surprise that it's now making its mark on the search for extraterrestrial intelligence. SETI. No, we're not talking about the menacing Skynet, the Matrix's relentless machines, or Star Trek's Data. The AI in the spotlight is powered by machine learning algorithms designed to tackle very specific tasks, like the one you're chatting with on ChatGPT. So, how does AI help in the hunt for alien life? To answer that, let's turn to astronomer and SETI researcher Eamon Cairns from the University of Manchester. He likens it to the classic needle in a haystack problem. Eamon Cairns says, you basically treat the data as though it's the hay. Then you're asking the machine learning algorithm to tell you if there's anything in the data that isn't hay. And that hopefully is the needle in the haystack. Unless there's other stuff in the haystack too. And here's the kicker. That other stuff is often radio frequency interference, RFI. But the AI is no pushover. It's trained to recognize the various types of RFI we've already identified. So those signals, the familiar patterns from mobile phones, local radio transmitters, and our electronic gadgets, are the hay. But AI's magic lies in its ability to sift through this data at a pace and scale that would make your head spin. It excels in pattern recognition, rapidly identifying signals that don't fit the mold of known RFI. It's like having an entire army of experts with eagle eyes tirelessly examining the cosmic haystack. This revolutionary approach is transforming the search for extraterrestrial intelligence, making it more efficient and productive than ever before. AI not only spots candidate signals faster, but also filters out the common RFI noise, enabling researchers to focus on the truly intriguing anomalies. Now let's talk about the elephant in the room, the limitations of us mere humans. Well, our passion for exploration knows no bounds. The vastness of space and the complexity of data analysis can overwhelm us. AI, on the other hand, is tireless, relentless, and unfazed by the sheer scale of the cosmic haystack, injecting signals into the data, and then the algorithm learns to look for signals that are like that. Explains Steve Croft, an astronomer working on the breakthrough Listen SETI project at the University of California, Berkeley. He describes it as, you basically introduce certain cues into the data, and then the algorithm learns to recognize those cues. This algorithm's primary task is to identify familiar patterns and ignore them. However, if it comes across something unfamiliar in the data, it raises a flag, indicating that humans need to investigate further. Cairns further elaborates on recent efforts, saying, lately we've been using a machine learning algorithm to sift through breakthrough Listen data. This data had already undergone meticulous scrutiny through traditional methods, yet even after being trained on the known data, the algorithm managed to identify new signals. It was a project led by Croft and an undergraduate student, Peter Ma from the University of Toronto, who developed and employed the algorithm. They used it to analyze data gathered from 820 stars, observed by the 100-meter radio telescope at the Green Bank Observatory in West Virginia. The dataset contained a staggering 489 hours worth of observations, teeming with millions of radio signals, most of which were man-made interference. The algorithm meticulously inspected each signal and uncovered 8 anomalies that had eluded previous analyses. These 8 signals appeared to originate from 5 different star systems, although their significance remains uncertain. They have not repeated, which is a fundamental criterion in SETI for considering a signal as potentially interesting. They will likely turn out to be radio frequency interference, RFI. However, this discovery holds value as it contributes to training the next generation of machine learning AI to filter out similar RFI in the future. Machine learning algorithms fall into 2 main categories. The first is supervised learning, where you feed the algorithm extensive data, teaching it everything you know. The second, unsupervised learning, is a distinct approach involving feeding the algorithm data without imposing any preconceived human notions. With a fully unsupervised approach, you just throw all the data in, stir the pot, and let the algorithm figure things out on its own. For instance, consider a dataset containing images of tables and chairs. In supervised learning, you train the algorithm using labeled images of table and chair. In unsupervised learning, the algorithm must independently discern between the two, potentially grouping items based on their visual similarities, like identifying objects with backs as chairs and those with long tops as tables. Karen's shares an interesting project led by Adam Lesnikowski of NVIDIA, a company renowned for its graphics cards and now a leader in artificial intelligence. Lesnikowski, along with Valentin Bickel from EHT Zurich and Daniel Engerhausen from the University of Bern, conducted a test using unsupervised machine learning to identify artificial objects on the moon. They fed the algorithm images from NASA's Lunar Reconnaissance Orbiter and challenged it to distinguish lunar features like craters and rills from unusual objects. The experiment succeeded as the algorithm accurately pinpointed the Apollo 15 lunar lander on the moon's surface. The concept behind this effort is the idea that advanced extraterrestrial civilizations might have visited our solar system and left behind probes or artifacts on planets, moons, or asteroids. There's even the possibility of an active probe observing us at this very moment. Karen's mentions the interest of some colleagues in deploying orbiters equipped with machine learning algorithms. Such spacecraft could scan planetary surfaces in our solar system to identify anomalies that might be alien probes, potentially millions or billions of years old. Unsupervised learning's real-time capability allows for on-the-spot assessment of images without the need to transmit all data back to Earth for human review. In today's era of big data, machine learning AI plays a pivotal role in astronomy and SETI, offering speed and efficiency that often surpass human capabilities. However, it's crucial to note that humans remain closely involved in the process. While AI can flag intriguing signals, humans are still responsible for investigating further because the algorithms have their limitations. Yet, there's the prospect of AI evolving to become smarter. Researchers at institutions like Google DeepMind are working on artificial general intelligence, AGI, which has broader adaptability. Unlike today's specialized algorithms, AGI could learn and grow across various domains, potentially surpassing human intelligence. The implications of artificial general intelligence for SETI are captivating. We've already witnessed machine learning algorithms mastering complex games like chess and Go, outwitting human experts. An AGI could revolutionize the search for alien life by exploring uncharted avenues beyond human biases and experience. It could map out diverse possibilities for conveying language and communication through signals and optimize astronomical search strategies. But there's a question of whether AI, even if it figures things out, will be able or willing to explain it to us. Creating an artificial general intelligence is like crafting something very different from us, almost like an alien. This AI might be challenging for us to communicate directly with. Karen's notes: we might find it very hard to directly communicate with it. We might have some hierarchy of translators, and at the top of that hierarchy is an intelligence that would decide on much smarter ways to look in SETI. If it makes contact, then how does that filter down to the biological intelligence, the stupid guys, us? This could result in a sort of Chinese whispers scenario, where the information is passed down through the hierarchy and potentially simplified before it reaches us. The AGI might even hold back complex details it deems too advanced for our comprehension. If AGI detects a SETI signal, we might not get the full story. Of course, these are just speculations. In the present, AI serves as a potent tool that's speeding up our quest to find signs of extraterrestrial life. One thing is certain. If we ever do discover a signal from another world in the future, AI will have played a significant role in making it happen. As AI continues to evolve and shape our understanding of the universe, it's safe to say that this technology could be the key to unlocking the secrets of the cosmos. However, with great power comes great responsibility. The development of artificial general intelligence, which goes beyond the specific tasks AI is currently designed for, could raise complex questions and challenges, especially in the quest for contact with extraterrestrial civilizations. So, what do you think? Share your thoughts in the comments below, and don't forget to hit that like button if you've enjoyed this video.